with your IGSCE tests. I'll give you guys about 5 more minutes to finish up any last minute questions you have here. Feel free to. Huh?
You give me my paper back.
Well, if you give me your paper, that's fine. But if you did not give me your paper, you should probably wrap up over the next 5 minutes. Okay?
你写呀？你写完了？真的吗？好可怕呀！发现自己怀疑是40真确。写诗，让你写诗。我怀疑那个男娘皮像周枫叶，1米8多美人。能不能别这样？周枫叶，老师，我们的周枫叶好像不是满分。
Guys, do I need to move you? Okay. So whip out your test if you got it. We got 1, 2. Anybody else? That looks like a physics test. Okay. 3 here. Are you guys absolutely done? You're sure? Because then we can review it. Okay. If that's the case, I'll give it back. We're going to do the quick review, and then I'll grade your efforts a little bit later, okay? So Ben, SR, Kiki, I hope that's Kiki.
It's me.
Jimmy, and Owen, make it work. So has everybody marked their scheme yet? Yes or no? Attention. All right. Who wants to give attention? Most people say yes?
Yes.
All right, sorry, David, got to do it.
Do I just go tomorrow at lunch?
说李子琪，温馨提示，我们今天2节 AP Math， 早上1节，下午1节。
You want to send it to the
下午最后1
This
节
is the same one. Quantity. All right, so real quick, I'll give you guys 5 minutes to make sure you wrap up, finish all the questions. Okay? Just 5 minutes. If you're absolutely sure you're done, you can let me know and we can start the review. Check your answers. I think many people got maybe 50%, so when I looked through them, okay. You understand your answers? Guys, when you give responses on multiple choice, you should still show some calculations, okay? Some of the questions are calculations based. So show your work. Even though on the real test they're not going to care, you should still write it for your own reference. Okay? But it looks like nobody's writing, so you want to review it then? Right. Afterwards, we're going to give the theory paper. Okay, so me and the other teacher, we will give the theory portion of this test for the next round. Okay? All right. So first off is vector quantity. What do we know about vector quantities? Well, actually, we can probably draw on here. Let's make it a little bit thick. What's the meaning of vector quantity?
对，还有这个给我，
Both
还有
magnitude
哇
and
塞
unit.，
你那会好了。
Did everybody hear Tracy?
Both magnitude and unit.
Magnitude in unit? You're close.
And direction?
Yeah, and direction. Okay. I expect you guys to fix up your classmates' responses. So which one of these has a direction? They all have magnitude.
Wait.
Weight up. Yes. Okay. So for this one, we're going to say D.
Yeah.
Okay, what is weight really? It's a force of gravity. So weight is just a fake name that we give to force gravity. Force gravity is really what it is. And we all know that forces are basically arrows. Okay. Next up, we've got a graph. Okay. Shows the car traveling through a town. We want to know when, during this graph, is the car decelerating. What's the meaning of decelerating? Uh-oh. Slowing, yeah, sure. Well, the direction matters. That's why I'm a little worried, okay? If we're going to assume that they're traveling in the positive direction, yeah, the velocity would be decreasing. So here they say speed. I guess that's fine. You want to make sure we're paying attention to these axes. Most important thing in physics and chemistry. You want to know what are the axes of your graph. So where would the speed be decreasing? E, all right. Okay. Terminal velocity, some people were confused about this one. Okay, so we're going to drop something. We want to know, again, these axes, is time and speed. Right? So what's the meaning of terminal velocity? I actually drew it on the board last time. If something falls from the Eiffel Tower, what happens eventually? It starts accelerating from the beginning. Yeah.
And then as it reaches the highest velocity and keeping a constant velocity.
Exactly. Right. You don't maybe really need to know why that happens, but eventually things are gonna stop. Right. So it kind of looks like a few of these graphs show that. Which one would be most accurate?
C.
C, right? So it's going to start off pretty fast, and then the acceleration will start to have an impact on the velocity. Right? So again, they're using velocity and speed interchangeably. Okay, I would stick with the concept of velocity. It's pretty safe for the future. All right, here we've got 3 different liquids with different densities. And we want to know which ones would float to the top of the container, which ones would float to the bottom. So how can we start this one? They gave us the mass and they gave us the volume. Density, right. So density is what over what?
M over V.
All right, there we go. Right, so we can just do it for each of them. Honestly, if you do a few of these, you can do it with just by looking at it, right? So automatically, which one has the highest density? The most grams per volume?
Y.
Y, right? That's going to be 80 over 67, okay, which is bigger than 1. So already we know that that's going to be at the bottom, okay? And you can probably eliminate all the other answers. You can divide it out, again, 120 over 200 is going to be a lot less than 100 over 120, so we can assume that A is correct here.
Yeah.
Okay. I don't know if they give you a calculator on the test. Did they give you a calculator?
Yes.
They do. Yeah, actually some of these questions definitely require a calculator. So, what's the meaning of a resultant force? Okay. So when we think of resultant force, it's sigma F, which equals F1 plus F2 plus plus blah, blah, blah. Okay? If we have multiple forces, but they all cancel each other out, you're not going to have a resultant force. That's going to equal 0. You got a positive here, a negative there, so you say bye-bye, right? So I did talk about this a little bit during the last session. Some people had a question. Okay? What did you guys say to it? B. Okay, going around in a circle. Okay. And that's because, like I said, in order for something to move around in a circle, it needs to have a force constantly pulling it inwards. That's it. Right? Everything else with constant speed, terminal velocity, that's a constant speed, that's equilibrium. Okay? Our forces are in equilibrium. Okay? Same concept with forces. Like I said, if they all cancel out, they'll be in equilibrium. So, which one looks like the forces are canceling each other out?
B.
Pretty easy. Why not A or C? Because why not A or C?
It's not from the central point.
Sure, yeah. I mean, they're not acting in the same axis, right? So if you're to put these forces on it, you can imagine it's going to just start spinning around. Right? Next up, we have a momentum one. Did anybody get this one? Let me see. What's some of Okay, what's our equation for momentum? For a collision? Okay, if you're ever confused, just go to the basic. Let me see what the basic equation looks like. Right? It's what was it? M1 V1 plus M2 V2 equals M1 V1 plus M2 V2, and this is all initial and this is all final. Okay. So the 2 is going to be the second sphere, Y, and then the 1 is going to be the first sphere that's already moving. So what can we already do based on the information we have? Is there any way we can simplify this? Do we have all these variables? We're solving for which variable?
We have mass.
We have mass. Good. So we have all of these already. That's easy. Because they're both identical spheres of mass 0.15. What's the variable that they're asking for? They're saying, what's the velocity of sphere x after the collision? So I shouldn't have said 1. I could say x and y, but whatever. Which variable?
Just put the formula and then calculate out.
Don't. I'm only trying to get you to identify the variable that we're solving for. I thought this would be easy. Or maybe it's 9 a.m. Irving, any ideas? Yes? Which one? Huh? Yeah, it's velocity, but we have 4 velocities, bro.
Which one is x, which one is y?
1 is x.
Oh, 1 is x,
Yeah.
so we
This is the
need to
first
find,
one.
so we need to find v1 up, like, right side.
Yeah, there you go. Okay, the base equation looks like this. If you want to label it x and y, They might do A and B, right? So we're looking for this guy,
怎么给我看？
okay? Mm, but do we have M2, V2? So let's start filling in these values, right? So mass is 0.15. What's the V1?
2.
2. Plus, what's M2, V2 initial?
I'm sure it's 1.5.
Sure. Then what's V2?
Good question.
Good question. Uh-oh.
Anybody
Anybody here is good English?
It's also 0.15 when I'm M2 because it says identical square y.
They're identical because of their masses. Their masses are identical.
Yeah, I think so.
Well, what does it say here? Second identical sphere 1, which is stationary.
0.
0。
Okay. That's
因
why
为
I said
那
this
个
is
我
a...
老师你是零啊，他问的是那个 V2 就是那
Oh, I
个
thought
Y
you were
的。
asking for the
Right.
mass.
No. Oh, well, we know the mass. It's 0.15, but I didn't write it because the V2 is already 0.
Okay.
Okay. So that's why automatically we can say this is 0. So when they say stationary, when they say at rest, things like that, we want to make sure we can interpret that English. Okay. Then what's M1, V1? Well, we're looking for V1, right? And the mass doesn't change.
V1
Then what's M2, V2? Of the Y, sphere Y.
force equal delta V times mass, so we need to find out the velocity first because we have the mass. So
So which equation are you using?
so
for impulse?
force equal mass times delta velocity. Delta V.
Uh-oh, you're close.
Is it?
Something delta V,
Mass.
Mass.
impulse.
Yeah.
I don't know what Cambridge is teaching you.
可是 mass 是在
Impulse.
是不是它为impulse是因为impulse 扭
You guys have textbooks
Yeah.
if you want to double check.
不是 mass 乘以 delta V 吗？
不是 math.
啊
No.
Momentum.
Okay, so impulse is a special equation.
燃射
F delta T.
啊？
force 好像是对的，对的。
Am I going crazy here, or do you guys?
啊？
因为启动了。
可是你是整的。
Unless there's something seriously different between the American and UK
这完蛋了我们。
terminology.
I think we're wrong. 搜一下。
Impulse equation。哦。不会吧？我们被真的答了。
That's weird.
What is FT?
Well, if you put in the units,
Why is like it has equation?
there's two equations.
Yeah, and delta T and N doesn't.
It have mass times delta V.
我就说
Oh, mass times delta V. Of course. Yeah. Well, you should be careful when you say
But we don't
mass
have
times
force.
delta
We don't have force and time here.
V. Exactly. So that should tell you something.
我操！我还以为我自己记错了，
我还以为我记错
我感
了，
觉我错的应该没有那么离谱。
吓死人了。
吓我一跳，真以为要完蛋
So。they kind of just rearrange
你
the.
们那应该是
Wait, what variable do they use for impulse? Delta P. Oh, that's good. Okay. So look at that. Your textbook admits that impulse is delta P. Are you okay, Tracy?
Yes. Delta momentum, change momentum.
So, like Jimmy said, there's no force. We don't have time.
Yeah.
So what can we do?
We have the first velocity, the original velocity, and we need to find out the terminal velocity.
Okay. You're getting closer, yeah. What does delta P really mean?
Changing momentum.
Okay, that means PF minus PI. right? So we're just saying how much, the units are the same. Look, this delta P and the M1 and the MV and the delta P, they have the same units. They have to. Because if delta P equals PF minus PI already, and P has the same units as MV, then it has to have the same units. That means it's okay to put it in this equation. Right? And so if our PI of our initial object was 0, right? So it's something minus 0. So that means our PF of, people are confused?
No, we're fine.
You're fine? Okay. So delta P equals PF minus PI of sphere Y, okay? That means the PF of sphere Y, and by the way, they gave us the delta P, it was 0.21. Therefore, what is PF? Final momentum.
0.21.
Yes, 0.21. So that means in here, what can we put?
321.
Yeah.
0.15.
Uh-oh.
Oh, no, no, no.
不用，这个直接就是
吓死我了。
Alright, 0.21.
好清楚的。
没问题?
没有关系。
没有问题。
Okay, cool. So if you do the algebra for this one, so that sounds a little bit weird because, you know, they say impulse. How can you put in the impulse for MV? Well, you kind of can, okay? They have the same units, so you're totally allowed. Alright, so what did you guys get for V1? We don't, ooh.
哎，不是，我相错了字母
0.09
了。
divided by 0.15.
The wall is bleeding, sorry. Would you guys calculate? Make sure you're dividing what by what? Plus 200, right?
0.6.
0.6.
Right, awesome. 0.6.
And it's going in the same direction.
Yeah, I hope that part is obvious, right?
Yeah.
If you're going forward, right, you can automatically, you know, delete these, okay? Because if you're crashing into something, well, that second thing is going to keep going in the same direction, okay? It's not going to pass through, right?
Especially if it's stationary.
Exactly.
If it's moving toward it, there's a chance that it's stationary.
It's possible. If one of them is very heavy compared to the other, it could go in the other direction. But automatically, you can get 50-50 chance. If you did the math, you'd get 0.6.
我就选了个 A， 给自己蠢蠢的。
我也选了个 A，
让他被自己
Everybody
笑
understands?
了。
All right.
觉得我们也能要点啊。
你知道我的鸡
Now let's try.
你也是个人才。
This one's going to be involved in energy. So you guys learned a bit about energy.
Yeah.
So this biker is starting from here. He's letting go. He's riding down the hill, and then he hits his brakes. He stops. Okay. So how much energy? What form of energy did he have at the top? What form at the bottom? Then what form at the end?
学校的第一个选的是凯特。
He had the gravitational potential energy with pushing him down the hill. And then,
我第一个同学
then that transferred to kinetic energy.
Yeah.
And eventually using the brakes turns to transfers to kinetic energy to form a phase.
Yeah, you have a thermal, right? So the brakes, it kind of messes things up and it steals all the energy. So that would be 8. Okay. You guys understand that process? The trade-off between potential energy and kinetic energy is pretty easy. But you should recognize, where does thermal energy come from? Right? And there's a variety of places, friction, brakes, things like that. Okay?
这个就自己我占了。
This is also a potential energy problem. Potentially a potential energy problem.
D.
D. Everybody says D?
Yeah.
Yes.
Okay, pretty easy. Right? We're just
啊，不好意思啊，校叶全对哦。
the MGH1.
不好意思，对呀。
好
厉害，很厉害。
校叶全错，校叶全错。我12点跑到系里乱 软软的。
你凑什么分？
Okay? So just be careful because they might trick you, alright? They might label H1 as H2 or H2 as H1. So as long as you look at the labeling, you'll be fine. Okay, so that's B. Alright, 10. We're going a bit slowly. You guys know anything about power? What does power mean? You learn about forces, then you learn about work, and you learn about power. So what does power mean?
A character in Chainsaw Man.
Character would be what?
Chainsaw Man. Do you know the manga?
Yes, of course.
Oh really? Okay.
You can put that down as your answer. Blacker, Evelyn, you guys okay?
第一题吗？不会的，所以我选 D。
I can't remember why.
第一题差点。
可以做两个
B and D. Uh-oh.
直接除吗？
但是那个
直接除就是
就是power 就是
那就除以7乘60，
对
420秒。
对，然后最终一题。
Did you guys forget about the very simple equation of
只有那
this?
个除以
work divided by time.
Yeah.
Yes.
Energy divided by time.
The idea is you care about how quickly you're able to do something, right? So power would be work over, I guess, yeah, delta. Okay, so how much work did we do? We care about how quickly we did it. If we did it very quickly, that means we had a lot of power. If we did it very slowly, that means we had little power, okay? So what's the work done?
个十百千万。
Push by 10, exactly, right? 460,000. The hint here is it's in joules, okay? Anything that you see that's in joules, that's work, that's energy. Time, how much time?
400 seconds.
Wow, amazing. So that's 420, huh? 7 times 60.
Oh, that's what I
idea.
I'm gonna slow things down for people.
did. I can't remember. I got it right, but I can't remember why I took the second.
王家学，王家学。
Yeah,
I think it's because I did minutes and it wasn't an answer. So then I went to seconds.
Oh, they didn't have minutes as an answer?
I didn't think so.
These guys suck at testing. What's up, miss?
Can I go to the toilet? What? Can I go to the toilet?
Toilet?
Oh, that's good.
Give me the answer.
Which
I'll do
one?
this.
The one that we're doing.
10.
The-
啊？
Are you paying attention? Which one we're doing?
I think it's 10. I remember power.
I remember the answer is 10.098.
It's A.
Okay, what's the answer to this, dude?
It's A. It's one.
It's A?
It's 1,100 something.
Okay, 1,100. Oops.
我记得是1089，然后
Okay,
1089
yeah.
东西，1089
And so they'll change it to kilowatts. They want you to understand the concept of the prefixes. Okay? So now you can go to the toilet.
Thanks.
All right, swimming pool pressure. Okay, so this is kind of fluids, right? We've got a giant tank. We've got some water in there. Let's see. So what's the relationship between height or depth and pressure?
Directly proportional.
Directly proportional. Very good. Okay. So relation between pressure with the bottom of the pool, right? So direct. So what's the equation of pressure?
Force divided by area.
Okay.
Rho GH.
I think rho gh is a little bit more relevant here. Okay, so sometimes in physics, there's multiple, it can equal multiple things, right? So we'll have our rho gh. So notice how here there's no crazy stuff going on. There's no exponents, there's no square roots, there's no drama. So that's why we can say it's linearly related. Okay? Why can gas be compressed? Just a concept. Some people actually got this wrong.
Hey,
I got this one.
get
Thank you for your honesty.
because the particles are far apart.
Yeah, dude, they're super far apart. And so because of that, if you're able to push down on them, you can squeeze them closer together. Okay? Alright, movable piston, very similar. Okay. What's going on in this situation? They're saying they're taking this gas, they're heating it up, right, Kiki? They're heating it up, and then what's happening? Interpret the situation, the English. If you can understand the situation, doing the physics is pretty easy. Expand. Right. Because it's a movable piston, so it's going to expand this way. So what are the variables about gas? Which variable? If you have a gas, what's the variables? Do you know what a variable is?
Yes.
Okay, so if you have a gas, how can you describe that gas? It has a certain blank, right? We've got temperature, we've got volume, we've got pressure.
Yes.
Okay? So think about this situation. What's happening to the temperature?
Right.
Increasing because it's heated. So it increases. What happens to the volume? Where? And then pressure doesn't change, decreases. Right, they even told us constant pressure. So, you can say nothing. Right. So all they're really asking here is forget about the piston, forget about the complicated diagram. What they're really asking for is what happens if we take a gas, we increase the temperature and increase the volume and keep the pressure the same. Right? Force, what happens to force when they crash into each other? Increases because of higher velocity, right? So we know it's one of these. But how often they crash into each other? Yeah. It's a bigger volume.
More space.
Oh, it goes that way?
Yeah, if we have a, that goes that way, definitely.
Okay.
Yeah, if we've got a bigger tank, then how often are they going to hit each other, these molecules? Not very often. So now we can say decreases. So that means A is going to be our right answer. Okay, what makes the Cambridge multiple choice easy is because if you can eliminate just two of them, you have a 50-50 chance. This is the extended version of the test. That's a pretty good deal. Yeah? That even having a 50-50 chance will help you out a lot. Okay? On a warm day, a carton of fresh milk, you cover it with a wet towel. So why does that reduce the temperature?
A.
Exactly. A is 1. Right? Mostly because remaining water becomes cooler. So which water molecules are going to evaporate? All the hot guys, they're going to evaporate, leaving behind the cold guys. Okay? This one was a mathish problem. Actually, somebody during the study hall asked me about this question. And maybe in the other class. How do you guys start this one?
Wrong.
You started it wrong. Thank you for your honesty.
Guess.
You guessed.
That's what I do on every test I say.
Anybody have a way to set this up? Just to set it up. They're saying you're heating up some water. The water has a C, it has an M. has a delta T.
Oh.
Then we also have some plate of oil. It has an M, it has a C, it has a delta T.
就是它。
What's the trick here though? The trick here is it says 2.5 times and 1.1 times. So when you see that on any kind of logic exam, what should you do?
2.5x.
Right.
1.1x.
That's math question. My math sucks.
Water. Well, it's not math, it's just logic.
My logic sucks.
We are fixing that in this class, right? So we know that we're going to use which equation? What's the big equation for this?
MC delta T.
Okay. MC delta T. Is that an equation?
Equals to Q.
This is an equation?
Yeah, equal to energy.
Okay. Heat energy, which is Q.
Yeah.
Is that how they write it in your book?
Yes.
Yes.
Okay, good. I'm very happy when the UK and America get along with things. So what is the M, what is the C, what is the delta T?
And is what?
The density can be considered the same as the mass, because it's the same amount of stuff. They said equal volumes. So if we say equal volumes, density and mass is the same thing, right? So M equals,
Math.
yes, it's mass.
Density times volume.
Okay, but we said that the volume is the same for both.
Yeah,
So we can say that mass is the same
1.1.
concept.
Density times x.
Okay, well we're just going to say the mass is 1.1.
Okay.
Okay. Again, see, this is the trick. We're simplifying things to make them easier. Then what is the C?
C is 2.5x.
Right. Is it really necessary to say 2.5x?
No, because x is 1. Yeah.
We can just set, like, right?
Yeah.
Just set those 1.
Okay.
Is 2.5 times 1? Yes. Is 1.1 1.1 times 1? Yes.
Okay.
Okay. So, and then our delta T's. What's the delta T for water here?
1, 10.
Yeah, we want to say plus 10, just to make sure. Because sometimes temperatures can decrease, but what's the delta T for oil?
200.
Good question. Can anybody read this
10.
Still
last
times.
line? It's still 10, right?
Yeah.
Plus.
3 times 10.
Wow! Oh, we out of time already. Okay, we stopped at 15. Right. So,
Next, only 5 more questions to go.
yeah, I know. But it's worth it. We gotta flesh it out.
Do we keep our multiple choices here?
No, I'll try to hand them in. I'm going to grade them and give you back some points.
喜欢我们在期望送给你。
你要送给欧欧的，他会开心死。
我下次上台就用这个国片。
你这是买它吗？
Next time I will give you the theory. Make sure your name is clearly written.
哎，王山怎么还在等我？
这是什么逼课呀？我宣布新的一个学期，最惨逼的一学期星期3，
去上个学期最傻逼一天
星期4，
星期二，
星期4。
为什么？
因为星期4是那个一堆 double math double English double chemistry。
但星期二有